This is Mrs. Zappia with Lesson 11, Constant Rate. Student outcomes for this lesson. Students know the definition of constant rate in varied contexts as expressed using two variables where one is t, representing a time interval. Students graph points on a coordinate plane related to constant rate problems. Pause the video and copy the essential question. How do you graph points on a coordinate plane related to constant rate problems? Example 1. Pauline mows a lawn at a constant rate. Suppose she mows 35 square foot lawn in 2.5 minutes. What area in square feet can she mow in 10 minutes? In t minutes. What is Pauline's average rate in 2.5 minutes? We will let C equal Pauline's constant rate in square feet per minute. C equals 35 over 2.5. What is Pauline's average rate in 10 minutes? We'll let A represent the square feet of area mowed in 10 minutes. So her average rate in 10 minutes will be A over 10. The constant speed is A square feet in 10 minutes. Then, using our transitive property of equality, we know that 35 over 2.5 is equal to A over 10. This is a proportional relationship. Next, we'll write our linear equation in two variables and solve for A. That gives us 2.5a is equal to 35 times 10. Simplify the left side. Nothing to simplify. 2.5a. Simplify the right side. 35 times 10 is 350. To solve for a, divide by the coefficient of a. Divide by 2.5 on both sides of the equation. When you simplify, we find a to be equal to 140. What that means is that Pauline mows 140 square feet in 10 minutes. So we've answered the first part of the question, how much can she mow in 10 minutes? Next, let's answer in t minutes. We'll write a two-variable linear equation to express the area of the lawn, y, Pauline can mow in x minutes. Remember that we were using y over x on the previous lesson, and y represents the distance, and that is the amount mowed. And x represented the time. In this lesson, we will be using t for time. So the rate is 35 over 2.5, and that represents 35 square feet in 2.5 minutes. That is Pauline's rate. Then that is proportional to y over t, which is the amount mowed in t minutes. Then rewrite that proportion as a linear equation in two variables. That gives us 2.5y is equal to 35t. Now we want to solve for y, so we divide by the coefficient 2.5. That gives us our linear equation in two variables. 35 divided by 2.5. Now that can be left as a fraction. 35 over 2.5t. This is our linear equation in two variables relating the amount of lawn mowed in T minutes or in X minutes. This linear equation represents the constant rate at which Pauline can mow a lawn. Next, we'll fill in a table and organize data to find out how many square feet Pauline will mow in 0 minutes, in 1 minute, in 2 minutes, 3 minutes, and 4 minutes. Our linear equation then we will use our linear equation each time to determine the area. Y equals 35 over 2.5 times the value of t. And t is from this column in our table, which is 0 minutes. In 0 minutes, so you multiply these two values and get your amount mowed. And the answer is 0. Does that make sense? In 0 minutes, you mow 0 amount of lawn. Next, we'll figure it out for 1 minute. Y is equal to Pauline's rate times 1 minute. And that answer is 14 square feet. Then we have Y equals 35 over 2.5 times 2. Now, can you figure that out mentally? If you double the minutes, you would expect to double the amount of lawn space, and that would be 28. Complete the table. Make sure that you practice this calculation and do not simply copy the answer so that you will know how to do it as well. This is 35 divided by 2.5 times 3, and that answer is 42, and the next answer is 56. On a coordinate plane, we will let the x-axis represent time, t, in minutes, and the y-axis represents the area of mowed lawn in square feet. And then we will have the following graph. Apparently the graph has been deleted from your book, so I will put a copy of it on the right side of the page in a moment. You may want to pause the video and sketch this graph onto your paper as well. To graph the points, we have 0 minutes and 0 square feet, and that would be at the origin 0, 0. Then we have 1 minute and 14 square feet, over 1 and up 14. Next, 2 minutes and 28 square feet, so we go over 2 and up to 28. Then over to 3 minutes and up to 42 square feet. And finally, the ordered pair, 4 and 56. And that represents 4 minutes and up to 56 square feet. And that is graphing our data of our constant rate for Pauline's time to mow a lawn. Go ahead to the next page, and we're going to do on your own example 1 together. Juan types at a constant rate. He can type a full page of text in 3.5 minutes. We want to know how many pages P Juan can type after T minutes. Write a linear equation in 2 variables that represents the number of pages Juan can type at any given time interval. Let C equal the constant rate that Juan types in pages per minute. We're given the rate C equals 3.5 minutes for 1 page. 1 over 3.5 minutes. Remember that time is your denominator. Then we also know that C is equal to the number of pages typed in the time interval of T. Therefore, our proportion will be 1 over 3.5 is equal to the number of pages typed over the time interval. Next, write your linear equation in two variables using your cross product. That gives us 3.5 times p is equal to 1t, or just t. Next, we need to solve for the variable p, so we can determine the number of pages he types at any given time interval. To solve for p, we divide by the coefficient 3.5. Simplifying, p is equal to 1 over 3.5. I'm going to use the decimal 3.5 times t. Do you see what I've done from this step? T divided by 3.5 is equal to 1 over 3.5 times t. This is our linear equation in two variables that represents the number of pages one can type in any given time interval. Part B. Complete the table below. Use a calculator and round your answer to the tenths place. Our linear equation is pages typed equals 1 divided by 3.5 times t, where t is the time it takes to type the pages. So we're going to substitute the value of t in each equation. P is equal to 1 over 3.5 times 0. P is equal to 1 over 3.5 times 5 minutes. The number of pages typed is equal to 1 over 3.5 times 10 minutes. The number of pages typed is equal to 1 divided by 3.5 times 15 minutes. The number of pages typed is equal to 1 divided by 3.5 times 20 minutes. Using your calculator, you can multiply the right side of the equation to find the answer. So you'll be multiplying, first divide, then multiply by 0. First divide, then multiply by 5. Divide, then multiply by 10, etc. So our first answer is 0. In 0 minutes, you can type 0 pages. Our second answer, 1 divided by 3.5 times 5, and that answer is 1 3/7, and it rounds to 1.4. Remember to round to the tenths place. Pause the video and complete these calculations to complete the table. Check your work for the number of pages typed. Next, graph the data on the coordinate plane. To graph the data, use your ordered pairs. Our first ordered pair is 0, 0. Your graph, the line of 0 here, it looks like it has been edited and removed. So that point 0, 0 is not actually on the graph. Be careful graphing that data. Your next ordered pair is 5 minutes, 1.4 pages. Over to 5, up to 1.4. The next ordered pair is 10 and 2.9. So we go over to 10 and up to 2.9 to graph that ordered pair. Pause the video and graph the last 2 points. Question D. About how long would it take Juan to type a 5-page paper? Now this is estimating. It says about how long. Since 5 pages is between 4.3 and 5.7. Okay, so we have 5 pages right over here. 5 pages is between 15 and 20 minutes. Here's the 15 and 20 minutes that it took. So we're looking at the data over here. It would take between 15 and 20 minutes. We'll go ahead to the summary. In this lesson, you have learned constant rate problems appear in a variety of contexts, like painting a house, typing, walking, water flow, etc. We can express the constant rate as a two-variable equation representing proportional change. We can graph the constant rate situation by completing a table to compute data points. There are several problems that we did not do in this lesson. They would be good practice questions for you when you are preparing for your assessment.